This is a systemic autopsy. Our subject is the global semiconductor supply chain. Our focus today, the single point of failure that underpins the entire digital world.
The assessment is stark, and let's be very clear about this. The operational continuity of one facility in Veldhoven, Netherlands, well, that's the critical variable determining the function of our modern civilization. If it fails, the consequences are absolute.
This briefing will proceed through 5 core findings. We'll start with the architecture of this dependency, then move to its internal vulnerabilities, the external threats it faces, and the high-stakes gamble now underway for its future. And finally, we'll conclude with an assessment of what we're calling the 2026 endgame.
Okay, finding 1 concerns the architecture of dependency. The Dutch company ASML isn't just a market leader, it's a structural choke point. It is the sole global provider of the technology required for advanced chip manufacturing, period.
The core of this is a technology called Extreme Ultraviolet lithography, or EUV. It's the only method we have for patterning the microscopic transistors that power everything, from AI to advanced defense systems. And right now, there is no alternative. None.
The vulnerability here is rooted in fundamental physics. The wavelength is just 13.5 nanometers. Now, that's so fine, EUV light gets absorbed by almost everything, even the air it travels through. This means the entire multi-ton machine has to operate in a near-perfect vacuum. It's an incredibly powerful process, but it's also inherently deeply fragile.
And the consequences of this fragility, they're systemic. The sectors you see here are not just users of this technology, they are existentially dependent on its uninterrupted function. So a halt in Veldhoven means a halt in progress across the entire spectrum of modern technological society. Now, for our second finding, this exposes an even deeper vulnerability. See, the choke point isn't just ASML. When we analyzed the supply chain, we found a monopoly within the monopoly, a fulcrum located in Germany. So if ASML is the most visible part of this choke point, we have to ask the critical question, where is the true point of systemic failure really located? To find that, we have to look inside the machine itself. When we dissect an EUV machine, 2 German firms pop up, Trumpf and Carl Zeiss. They are single-source suppliers for the most critical subsystems. Trumpf provides this unique CO2 laser that ignites tin plasma to 220,000 degrees Celsius. And then, Zeiss provides the optics that capture and focus the light that comes out. Without these 2 suppliers, ASML simply cannot build a single machine. The precision that's required here is, well, for all practical purposes, it's impossible to replicate. Zeiss themselves put it this way. If their mirror were scaled up to the size of Germany, its largest imperfection would be 1/10 of a millimeter. This isn't a capability you can just duplicate on any reasonable timescale. It's just not possible. Our third finding shifts from internal fragility to external threats. Our assessment is that the current geopolitical landscape constitutes a state of active industrial warfare, and the objective is what we call lithographic autarky, or complete self-sufficiency. You have 2 strategic doctrines in direct conflict. The United States is using a small yard, high fence policy, basically using export controls to deny access to the choke point. In response, China is running what's essentially a Manhattan Project-style initiative to achieve technological sovereignty and just bypass this whole containment strategy. Our intelligence confirms that by early 2025, China activated a functional EUV prototype. Now, it doesn't copy ASML's laser-produced plasma, or LPP tech. It uses something different. Laser-induced discharge plasma, LDP. It's way less powerful, sure, but here's the kicker. It crucially bypasses key Western patents. That makes it viable for producing strategic, low-volume chips for their military and state AI projects. China's commitment to this is crystal clear in their current methods. To make advanced chips without EUV, they're using older machines, deep ultraviolet or DUV, in what can only be described as a brute force process. The results? A reported yield of just 33%, and it costs them 50% more than their competitors. Now, economically, that's a disaster. But for them, strategically, it's a necessity. So, finding 4. We analyzed the next generation of this technology. It's known as High-NA EUV. We assess this not as simple progress, but as a very high-stakes strategic gamble that introduces immense financial and technical risk into the entire system. The price to play this game is $380 million. That is the price for one machine. A cost like that fundamentally alters the entire economic equation of semiconductor manufacturing. And that cost has created a major strategic split. You have Intel, who's adopted an aggressive pioneer strategy. They're the lead customer, absorbing all that initial risk. On the other hand, you've got TSMC, taking a much more economically pragmatic approach, delaying adoption and just extending the life of the current, less expensive technology. What Intel is doing here is taking on a massive amount of what we call technical debt. In simple terms, they're paying the upfront cost in both money and engineering hours to solve all the early problems of this new tech for the entire industry. It's a huge risk, but if it pays off, they could leapfrog the competition. All of this brings us to our conclusion. The convergence of these factors creates what we are calling the 2026 endgame. The next 3 years are absolutely critical. 2025, China's prototype comes online. 2026 is when Intel's High-NA gamble really begins. By 2027, we'll know if it's even economically viable. And by 2028, the entire field changes again, with both TSMC and China projected to have their own next-gen capabilities. This whole conflict is accelerating. So the primary outcome of this High-NA cost wall is an extreme consolidation of power. The ability to manufacture at the angstrom era, that's the next frontier beyond nanometers, it's going to be restricted to just a handful of players who can even afford the ticket price. This autopsy has exposed a system of absolute dependency, deep internal fragility, and an escalating external conflict. The central question for 2026 is therefore this: in the coming Silicon War, who holds the weapon, and who's left holding the liability?